untitled.com's science section of competitive exams, and today we are going to see chapter number 17 on motions, measurements or distances. So this chapter covers 3-4 important modules like Newton's laws of motion, the energy theory and the types of energy, and certain miscellaneous facts about motions and distances. There are three main laws of motion, and the first law, that is the first Newton's law of motion, is also known as the law of inertia. It says that an object remains in the state of rest or uniform motion till a force compels it to change that tendency. And so, the tendency of objects to stay at rest or keep on moving is known as inertia. And this inertia is more for objects having a larger mass. There are some examples given to explain this concept. When a bus starts moving, our body is suddenly pulled backwards as our body is at rest, whereas the feet and the bus are in forward motion, and so our body is pulled backwards. Similarly, the reverse happens when the bus suddenly applies brakes. The body is in motion, whereas the feet and the bus are in rest, and so the body moves forward. Similarly, when a car takes a turn, our body swings as its motion was in a straight line, whereas the motion of the vehicle has taken a turn, and so our body keeps on moving in that straight line and so swings. Similarly, while we are playing the game of carom, we make a heap of carom coins and then take a striker and hit the lowermost coin. The remaining heap, however, remains in place due to inertia. And so inertia is a concept that depends upon the mass of the object. The more the mass, and so the more is its inertia. Hence, mass is also a measure of inertia. That was the first law of motion. The second law says that the rate of change of momentum of an object is proportional to the applied unbalanced force, which is in the direction of the force. What this means is, you have already experienced this second law in your life. For example, while playing a game of cricket, the cricketer catching the ball pulls his hand back to reduce the speed of the ball with time. And so this reduces the momentum or the force required to stop that ball. If he tries to catch the ball without keeping his hand backwards, then he has to apply a larger force because the ball is in a great momentum. Similarly, when an athlete jumps, he lands on a cushion to increase the time his body would take to reduce its speed to zero. However, if he lands on a hard surface, then the body has to immediately reduce its speed to zero, and this can cause injury to the athlete because of the high momentum of his body. The karate artist breaks a slab of ice with a single quick blow because he applies a large momentum on a very stable object, and so a large force is felt and it breaks the ice. A small bullet can kill a man easily because its momentum is great, whereas a heavy truck moving with a very small speed can also easily kill a person because of the large momentum. The third law, which is a very popular law, states that every action has an equal and opposite reaction. So when a bullet is fired, the force that causes the bullet to move forward also causes recoil of the gun. Similarly, when a sailor jumps out on the coast from his boat, he moves forward, whereas the boat moves backwards. So these are the three laws of motion: the law of inertia, then the law of momentum, and finally the law of every action having an equal and opposite reaction. The next topic is energy and the types of energy. So the first important type is kinetic energy. This is the energy that is present in the object due to its motion. So every object that is in a state of motion possesses kinetic energy. Potential energy is the energy that is possessed by a body or an object due to its position. And the sum of potential and kinetic energy is known as mechanical energy. Another important term here is power. Power is known as the rate at which work is done, and it is measured using the unit watt, which is spelled as, which is written as WATT. The commercial unit of electricity or electrical energy is kilowatt hour. Thus, electrical energy used by an appliance in a month is in kilowatt hour. However, this is also expressed in terms of units. So we say that the bill of a house is 3000 rupees because it has used 300 units. So here the unit means kilowatt hour. An example is given to explain energy. When we stretch a bow, the potential energy that is stored in it gets transferred into kinetic energy when the bow is released, and so the arrow also is pushed forward. Similarly, when an object is raised, its gravitational potential energy increases, and when it is released, this potential energy is converted into kinetic energy. So there is a diagram here to explain the various forms of energy. There is sound energy from vibration of objects. Luminous objects, that is, they emit light, have light energy. Objects falling from a high position, as I said, have gravitational potential energy. And as you can see that energy from one form is continuously converted into another form. So we say that the law of conservation of energy applies here, because energy can neither be created nor destroyed, but it can be converted from one form into any other form of energy. Certain miscellaneous facts have been given. First is, it was the French who first came up with the system for measuring standards for measurements. High speed winds, which are usually seen in cyclones and hurricanes, are accompanied by lowering of air pressure. And this phenomenon can also be studied in a very fancy way. Say you have taken an open water bottle and blow air into it and place a small paper ball on the opening of that bottle. When you blow the air into that bottle, the paper ball does not fall out because of low pressure. Similarly, next is the concept of time period. Time period is the time taken to complete one oscillation, and the time period of a pendulum is of a given length is constant. Pendulums were discovered by a famous scientist known as Galileo Galilei. Speedometer is used for measuring the speed of vehicles. Odometer is also seen in cars and bikes. It measures the distance traveled. The famous scientist Galileo Galilei is known for proposing an improved design to the telescope. He is also responsible for designing the barometer, which is used for measuring pressure, and the pendulum clock. Using his telescope, he discovered the moons of Jupiter and the spots on the surface of the sun. He also said that all planets revolve around the sun and not the earth. And because of this, he was highly criticized by the church. Finally, the three Kepler's laws are mentioned in the chapter. First is the law of orbits. This says that orbit of the planet is elliptical with the sun as one of the focus. Every ellipse has two foci and one of them is the sun. The second law says that the line joining the planet and the sun covers equal areas in equal intervals of time. And finally, the third law that says cube of the mean distance is equal to square of the time period. And it is this third law that also helped Newton frame his law of gravitation. It says that the gravitational pull between two objects depends upon the distance between them. So that is not covered here. However, we shall cover it in the next chapter. There is a chapter wise quiz which you should attempt if you are confident, and if you can score more than 80% marks, then you can move ahead to the next video. Right, so that was it. If you want to reach this website or you want to download some content, you can type www.upscfever.com. Then you can open our science section, and today we have covered chapter number 17, which is motions, measurements and distances. That was it. See you next time. Thank you.